Okay, so these are some review problems for the exam associated with Chapter 8. So we have basically four concepts. So I'm going to demonstrate two of them using the same problem, but on the exam there'll be two separate problems. So what I have is a system of linear equations, in this case just two, so that it doesn't take as much time to complete. So there are two ways to solve these linear equations, two basic ideas. One is to use an augmented matrix, and the other one is to find an inverse of the coefficient matrix. So the first one is we're going to use an augmented matrix, and there are two ways of solving those. One is called Gaussian elimination with back substitution. And the second way is called Gauss-Jordan elimination, which I'll write out when I do that. But in both cases, what we do is we take the system of linear equations and we write it as an augmented matrix. So this is the same augmented matrix. So you take the coefficients from the x and y and the right-hand side, put them into a single matrix. And the idea is to get 1, 0, 0. Well, for the Gaussian elimination, we need a 1, 0, 1. This we're not going to make that go to 0. That's the Gauss-Jordan elimination. Now, the first thing you want to do in these situations is you want to get a 1 up here in the upper left-hand corner. Now, looking at this, I've got -1 here. So what I could do is switch. One row operation is just to switch rows without doing anything. So what I've done is I've switched row 2 and row 1. Still the same two equations, just like taking these two equations and moving this one first. But I still have -1 there. So what I'm going to do is I'm going to take row 1 and multiply by -1. So that'll end up with 1, -2, -13, and then row 2 stays the same. Okay, so that's the first check, 1 in the upper left-hand corner. The next is to get a 0 here. So I'm going to leave the first row untouched, and I'm going to take my old row 2. So this is row 2. So the row 2 in the previous step, and I'm going to subtract 2 times row 1, and that is to get 0 here. So if I take 2 and I subtract 2 times 1, I'll get that to happen. So let's just write it. Let's write 2 times row 1 here. So I take my row 1, which is not changed, and multiply it by 2. So I get 2, -4, -26. So I'm going to take row 2, subtract 2 times row 1. So 2 minus 2 is 0. -3 minus a -4 is -3 plus 4, which is 1. And -23 minus a -26, well, that's -23. Okay, so we were -23 minus a -26. Well, minus a negative is positive, so this is 23 plus 26, which would be 3. Red here. So now, if this had not been a 1, then I would have just divided the third row by, the second row by whatever this coefficient was to make it a 1. So if this was like 3 and 6, I would divide both of them by 3 to get 1 and 2. But in this case, it ended up being a 1 just because of this particular row operation. So that's as far as you need to go for back substitution. So once you get to this point, you can write the corresponding, what these represent now, which is you take these coefficients and use those in front of the variables. So the first column is x, the second column is y, third column is the right hand side. So we're going to have 1x minus 2y is equal to negative 13, and 1y equals 3, or y equals 3. So then you can substitute back in. So you'll have x minus 2 times 3 equals negative 13, and x minus 6 equals negative 13. If you add 6 to both sides, you'll get x equals negative 7. Okay, so that's the solution. Now, when I ask you to use the next method, which is going to be called Gauss-Jordan elimination, you just got one more step to do. And that step is to take this matrix. So I wrote that down for you, but I'm just going to continue on here. So what I'd expect you to do on the test is to have this show this back substitution process. Yeah, let's just go ahead and write it out again. So I'm going to take this matrix, which is the one that results from Gaussian elimination. Okay, so there. So rather than stopping here and using back substitution, we're going to do one more row operation. And you can see what I want to do is get 0 here. So that's the only thing I'm going to change, is to get 0 here. This is going to change. This won't change. So I'm going to keep row 2 the same. And what I'm going to do is take row 1, my old row 1, and I'm going to add 2 times row 2. Because if I multiply this by 2 and add it to that, I'll get 0. So I'm going to write out here 2 times row 2. So here's row 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 3 is 6. So each one of those doubled. And then I'm going to take row 1. I'm going to add row 2. So 1 plus 0 is 1. Negative 2 plus 2 is 0. Negative 13 plus 6 is negative 7. And that's it. That's all you have to do. One more step to do Gauss-Jordan elimination. And then from this part, you can just say x equals negative 7 and y equals 3. Because I have 1x equals negative 7 and 1y equals positive 3. If I rewrote these, it would be x plus 0 equals negative 7 and 1y equals 3. So that's the same that I got in the previous step, so you should get the same answer. So this is kind of a simple additional step. Now when you have 3 by 3 matrices, you have to do more. You have to get zeros in this upper right hand corner, which consists of three elements instead of just one element. Okay, so that's Gauss-Jordan elimination. Now the next one is going to be finding the inverse of a square matrix. So I'm going to take the same set of linear equations. Like I said, the ones that I give you, it'll be a separate problem, so you have to start all over again. So the first thing you do is, instead of creating an augmented matrix, you create a coefficient matrix. Then you have a matrix that has the 2 unknowns, and you multiply those 2 matrices together, and the answer has to be the right hand side. So this is just a way of representing these systems of linear equations in matrix form and have matrix operations like multiplication. Okay, two ways to do this. One is to using, so finding the inverse using augmented matrix to find inverse. Now, we call this, typically this matrix A, we call this matrix X for the unknown, and we call this matrix B. So matrix A times matrix X is equal to matrix B. Now here, the augmented matrix looks different. You take the coefficient matrix, and you augment it with the identity matrix for 2 by 2, which is 0, 1, 0, 1. And what we're trying to do is we're trying to get down 1, 0, 0, 1, 1, 0, 1, 0, sorry. So we'll do the same thing in this case. We'll switch the first and second rows. Again, you have to do whatever's appropriate. We're going to multiply the first row by -1. Now here's a word of warning, is that what was the word of warning? You know, if you just write this down on your cheat sheet and you don't know what I did, you're going to be completely lost. So either you have to know it well enough that you don't have to worry about it, or you have to write some notes that tell you what am I doing here. And I can go back to it an hour later and know what I did. Okay, so just be smart about your note-taking skills here. Okay, so now what we're going to do, the same thing we did before, is we're going to take the first row, leave that as the same. We're going to take old row 2, and we're going to subtract 2 times row 1. So I'm going to write 2 times row 1 here. So take row 1, either here or here, it's the same thing, multiplied by 2. So you get 2, -4, 0, -2. Do we have something like that before here? 2, -4, yeah. We had this other one, which is, we don't have that when we do the inverse matrix. Okay. So now we're going to take row 2 and subtract 2 times row 1. So you get a 0, -3 minus a -4. That's -3 plus 4, which is 1. We're going to take 1 minus 0, which is 1, and 0 minus -2, which is +2. Okay, so that is the first thing we're going to do. Now, what we're trying to get is 1, 0, 0, 1. You'll see we've already got 1, 0, 1. Now, if this was not 1, then you would divide this entire second row by whatever I needed to get 1 here. Again, we're going to use the same row operation to get a 0. We're going to use a row operation to get this to go to 0. So what we're going to take is we're going to take the old row 1 and we're going to add 2 times row 2, because if I multiply this by 2, I'll get +2. I add it to -2, I'll get 0. So let me go ahead and write out 2 times row 2 here. So here's row 2. Multiply each one of these by 2. And then I'm going to add row 1 plus 2 times row 2. And that should make this part go to 0. So you get 1 plus 0. Well, before we do that, let's just copy row 2 out. Okay, add these two together. 1 plus 0 is 1. Negative 2 plus 2 is 0. 0 plus 2 is 2. Negative 1 plus 4 is 3. And now you can see I've got 1, 0, 0, 1. So what I have left over is this stuff here. So I can say that the inverse of matrix A is equal to 2, 3, 1, 2. Okay, so that's using the augmented matrix. Now most likely, if this is not just 1, then you're going to have to divide by some number, which will give you fractions. It just turns out this one that I picked out kind of arbitrarily has an inverse matrix that is all whole numbers, but it's not always the case, or all integers. Okay, so that's the first method. The second method is to use the equation, which says if you have a square matrix, 2 by 2 square matrix, which we do for A, then, so say this is the A matrix, then the inverse of A is you take, well, first you got to take 1 divided by AD minus BC, these numbers here, and then you multiply that number by the this particular thing, and I don't remember what it is. I gotta go look it up. So if you look at page 557, you get dA and then negative C, negative B. So what I'm doing is I'm switching these two diagonally, and I'm making I'm not switching them, but I'm making them negative. So for our particular case, our A matrix, here it is, it's 2, negative 3, negative 1, 2. So the inverse matrix is equal to 1 divided by 2 times 2, that's A times D, minus negative 1 times negative 3. So that's this part. And then you multiply that by the matrix where you switch these. So this goes there and that goes there. So they're both 2. So, and then here you leave them in the same place, but you make them positive. And you can see what I have here is I have 2 times 2, which is 4. I have negative 1 times negative 1, which is positive 3, but then you have a negative, so you have 4 minus 3. So you get, in the denominator you get 4 minus 3, which is 1, so 1 divided by 1 is 1. So you get 1 times 2, 3, 1, 2. And so the inverse matrix, now if this were a fraction, I'd multiply each one of these by that fraction. But in our case, that's not going to happen, but I'm pretty sure the one in the exam has a fraction in it. So now we can compare that. Let's compare that with what we have down here. 2, 3, 1, 2. Okay. So I want you to do both of them. One is to take your coefficient matrix A, augment it with an identity matrix, use row operations to get the identity on the left-hand side and the other stuff, whatever the resulting stuff is on the right-hand side. That's your inverse matrix. Now this method works no matter how big the matrix is. This method only works for 2 by 2 matrices. In both cases you got the same answer. So now to find the solution matrix, what you do is you take the A inverse of the A matrix, which we just did, multiplied by the B matrix. So we know what the inverse matrix is. It's 2, 3, 1, 2. And our B matrix is this, the right-hand side, which is negative 23, positive 13. Negative 23, positive 13. And then we use matrix multiplication to get this. So the inverse of A times B gives you the solution matrix. So the way this works is you take row times column. So you're going to have first row, first column gives you first row, first column entry in your result. It's going to be a 2 row by 1 column. These solution matrices are always 1 column. Okay, so you're going to have 2 times negative 23 plus 3 times 13, and second row, first column, you'll have 1 times negative 23 plus this times that times that. You get 2 times 13, and then you just do the math. So here you have 46, negative 46 plus 39. Here we have negative 23 plus 26. So that's just multiplying these things out. Get rid of parentheses. Negative 47 minus plus 39 is negative 7. Negative 23 plus 26 is positive 3. So you get that. That's your solution matrix. So x equals negative 7, y equals 3, which is exactly what we got using the other methods, using the augmented matrix. So those are the 4 methods. 2 using augmented matrices, 2 using finding the inverse and multiplying it A inverse times B. Okay, they're all going to be 2 by 2s. So again, you need to understand the process, not just write down what I've done here, because if you don't, it's not going to make any sense. So that's up to you. Okay, so those are the two problems. One using the augmented matrix, Gaussian elimination, Gauss-Jordan, and then one using the 2 techniques for finding the inverse. Okay, the next thing is just multiplying matrices together. So I'm going to give you 2 examples. And remember, the size of the matrix is important. So here I have a 2 by 2 matrix multiplied by another 2 by 2 matrix. So this is 2 rows by 2 columns. 2 rows by 2 columns. These have to be the same for the multiplication to happen. The outside is the size of the resulting matrix. So 2 by 2 multiplied by 2 by 2 is 2 by 2. Now, what I'm going to do is I'm going to do this as letter form. So the first matrix numbers can be represented by these letters, and then you can continue on in the alphabet like that. So what you do is you take the first, to get the first row, first column entry here, you multiply the first row times the first column. So that means AE plus BG. AE plus BG. Then you have the second, so here we have the first row, second column. So you take the first row times the second column. So you have AF plus BH. Then second row, first column. Second row, first column. That's going to be CE plus DG. And then this is the second row, second column entry. Second row, second column. So you have CF plus DH. Okay. So you can do that up here. A times E, AE, so that's 2 plus BG. So this is BG, BG. So it's going to be 2 plus 21 is 23. If you don't see how I get these, you can say A is 1, B is 3, C is 4, d is -2, etc., etc. So you're going to have to, again, decide how much you understand here. So the next one is we want the first row, second column. So we take the first row, second column. It's AF plus BH. AF, 1 times 5 is 5. And then you add BH. So it's BH. So it's going to be 5 plus 3. 1 times 5 is 5. 3 times 1 is 3. So you get 5 plus 3, which is 8. Then we have second row, first column. So you take the second row times the first column. That's CE plus BG. CE plus DG. So we take 2 times 4, which is 8, plus -2 times 7. So that's 8 plus -14, or 8 minus 14, which is -6. And then finally, second row, second column. So it's this times that. It's this times that. So it's CF plus DH. CF plus DH. So we get 4 times 5, which is 20, plus -2 times 1. So you get 20 minus 2 is 18. Okay, so that's a 2 by 2. Now I'm going to show you one more. So we have 2, 1, -3, 5, 3, 3. And we're going to multiply by 1, -2, 3, 4, 1, 7. Okay, so this is a 2 rows by 3 columns, and this is a 3 rows by 2 columns. Okay, so because these are the same, we can do it. The resulting matrix is the outside. So the outside is 2 by 2, so the answer is going to be a 2 by 2. Now again, I'm going to put all these letters in here: A, B, C, D, E, F, and we're going to multiply by E, F, G, H, I, J, K, L. And the resulting matrix is a 2 by 2, but I needed this big 2 by 2 because I got to put a lot of calculations. So we've got first row, first column, first row, second column, second row, first column, second row, second column. So what you have is AG plus BH plus BH plus CI. Okay, move this thing over a little bit, make some more space. So that's the result for the first row, first column. Then you're going to have C first row, second column, first row, second column. So you have A times, that's actually an A, isn't it? I'm going to make sure I do that right. Okay, so you're going to have A times J, AJ, BK plus BK plus CL. Okay, so add those products together. Then you're going to have second row, first column, second row, first column. It's going to be DG plus EH plus FI. DG, EH, FI. And then second row, second column, it's going to be DJ plus EK plus FL. DJ, EK, FL. Okay, so that's the things that we're going to do to get the result. So now I'm going to do this. And I'm probably going to, because there's, this is fairly big, I'm going to do this over here, kind of like that. And I'll just write it out. I'm going to write out the result. So 2 times 1 is 2, plus 1 times 3, which is 3, plus -3 times 1, which is -3. Okay, so this row and that column. First row, first column, first row, second column, first row, second column. Then I'm going to get negative 4, 2 times negative 2, 1 times 4 plus 4, negative 3 times 7, which is negative 21. Then I'm going to do second row, second row, first column, second row, first column. So it'll be 5 times 1 plus 3 times 3 plus 3 times 1. And then second row, second column, second row, second column. I'm going to have 5 times negative 2, which is negative 10. 3 times 4, which is 12. 3 times 4, 3 times 7 is 21. So we add these, you're going to have 2 plus 3 minus 3. So these cancel out. You just end up with 2. Here, these cancel out. So you just left with negative 21. 9 plus 5 is 14 plus 3 is 17. Here we have negative 10 plus 12, which is positive 2, plus 2 plus 21 is 23. So that is that. Okay, so I'm going to give you something. It's not exactly like this, but it's enough that if you understand the principle. So these equations are not going to work for the one that I give you, but the procedure into coming up with these equations. So if you understand how I did this, then the one that I give you, you should be able to use the same same logic. Okay, so that's the third of the 4 Chapter 8 problems, and the last one is finding the determinant of a matrix. So I'm going to give you a 3 by 3 matrix with no zeros, so you're going to have to do the whole thing here. Okay, so this is and you can only do determinants of square matrices. So the way this works, and because I'm going to give you a 3 by 3, you might as well, and there's no zeros, so there's no point in trying to do anything other than the first row, using the first row. What you do is you take this number 2, and then you create a 2 by 2 determinant by crossing out this row and this column. So what that leaves is 1, negative 3, 5, 4. Okay, so that's this part, once you mark out the first row and the first column. Now, when you go to the second entry, you subtract this. So you get plus, minus, plus. So this is minus. And then you take this number, negative 1, whatever that is. If it's positive, it's positive. And you multiply that by the 2 by 2 determinant by marking out the row that this number is in and the column this number is in. This row marked out with that column leaves these 4 items. So you get 7, negative 3, 1, and 4. And then finally you move to this point, because it's plus minus plus, it's going to be plus times 5. And then you have this 2 by 2 determinant. So you mark out the row that this number 5 is in and the column, and that leaves these 4. So you get 7, 1, 1, 5. Okay, now remember the determinant of a square matrix like this, a 2 by 2 square matrix, is just AD minus BC. So you take this times that minus that times that. So if we evaluate these 2 by 2 using that formula, you'll have 2, the coefficient in front, times 1 times 4, which is 4, minus 5 times negative 3, which is negative 15. So that times this times that minus that times that. Okay, take the next one. You've got negative times the negative, so that's positive 1. And then you take 4 times 7 times 4 is 28, minus negative 3 times 1, which is negative 3. And then finally you have this plus 5 and you take 5 times 7, which is 35, minus 1 times 1, which is 1. So then we have 2 times 19, because this is 4 minus a negative 15, so plus 15. Then we have 1. I'm just going to leave that off. 28 plus 3, negative a negative 3. And then plus 5 times 35 minus 1, which is 34. And so we'll get 38 plus 31 plus 5 times that is 170. And so well, I guess I could do that in my head. It's 69 plus 170, so that's 239, I think. 38 plus 31 plus 170, 239. Now, a lot of these things are available on your calculator, but, you need to know how to do it otherwise. So I'm just putting this into my calculator just to make sure I did it right. Okay. So there's something called the determinant, and I get a 239. Okay, so that's right. Okay, so that's it. So you've got solving systems of linear equations using Gaussian elimination with back substitution, then using Gauss-Jordan elimination. There's also solving systems of linear equations by putting them in coefficient matrix form, finding the inverse of the coefficient matrix using the augmented matrix approach and using the formula approach. You should get the same answer for the inverse. Then to find the solution, you take the inverse and you matrix multiply that by the B matrix, and the resulting 2 by 1 matrix is the solution matrix. The third step is to do matrix multiplication. So 2 by 2 times a 2 by 2, 2 by 3 by a 3 by 2, or I could do a 3 by 2 times a 3 by 2 times a 2 times 2 by 3. I won't do anything bigger than that. And then finding the determinant of a 3 by 3 matrix. So those are the things you need to know how to do. Plus, of course, everything else from the other tests.